Let's take a look at some of the math behind how we calculate the efficiency of an appliance. To start off, we need to know that the equation for calculating the percent efficiency is just like how you would find like the percent on a test or something. So we say that the percent efficiency is equal to the amount of energy that is outputted divided by the amount of energy that is inputted times 100%. Now the key here for energy that is outputted, this has to be useful energy. All the energy is always outputted, and it's always going to be equal to the energy that goes in. But a lot of times, energy is wasted in terms of heat. Heat isn't always useful energy, so we just want to know how much energy is coming out that we're actually making use of in a meaningful way. This first example tells us that we require 30 joules of energy to power a light bulb, and that it transfers 3 joules as useful light energy and 27 as heat energy. Given that we don't use light bulbs for heat, that 27 joules of heat energy is not useful to us. So, what do we have? Our givens tell us that we have useful energy output of 3 joules. We have an energy input of 30 joules, and we're solving for the percent efficiency. So again, we're just going to use the equation from before, where percent efficiency is equal to energy out divided by energy in times 100%. So let's go ahead and rewrite our equation and start plugging in what we know. So the energy output is 3 joules. The energy input is 30 joules. And that means overall, we have a 10% efficiency. So we can say, therefore, the efficiency of the light bulb is 10%. In this next example, we have a hairdryer that consumes 3,000 joules of energy. So that's our E in. And it transfers 600 joules as useful heat energy. So that's our E out. Again, we're solving for percent efficiency, and we're going to use the same equation as before. So our percent efficiency is equal to the energy output divided by the energy input times 100%, and that is 600 joules divided by 3,000 joules. That gives us a percent efficiency of 20%, and we'll finish off with a therefore statement. Therefore, the hairdryer is 20% efficient. Okay, so our last example says calculate the efficiency of a television that takes in 5,000 joules. So the E in is 5,000. And it transfers 1,000 joules as useful light energy, 1,500 joules as useful sound energy, and the remaining 2,500 is waste. So both the 1,000 and the 1,500 are useful here because a television is two things, right? It produces a light image in front of you and produces sound for you to hear. So the energy output in this case is going to be 1,000 joules for the light plus 1,500 joules for the sound for a total input of 2,500 joules. And again, we're looking for the percent efficiency, and we're going to use the same equations as before. So we're solving for percent efficiency, and that's equal to the energy output divided by the energy input times 100%. That's 2,500 joules divided by 5,000 joules. That gives us 50% efficiency. Therefore, the TV is 50% efficient. Thanks for watching. Make sure you like, get subscribed, leave a comment below, and check out our suggested videos. Make sure you hit the bell icon so you don't miss any future updates.